pocket. We got Dr. Emmanuel Torres, Quezada.
Yes, sir.
All right. And he's assistant professor and horticulture assistant specialist located on the Eastern Shore, brand new to Virginia. He'll probably tell us about that, but we're glad to have him, stolen from Florida. So I'm going to go ahead and turn it over to Emmanuel, and I'll cut the lights down again.
Thank you. Thank you, Roy. Hi, everybody. Thank you for having us. I'm going to move this shirt. It's going to be in the middle. Like Roy was saying, my name is Emmanuel Torres. I just came from Florida. I did all my studies in Florida. Back in the day, I was working with vegetables. That's why I'm a horticulture specialist. But my PhD was in strawberries. And most of the work that I did the past few years before I came here was in strawberries. So hopefully, I might have one or two things that I can talk about here. The only bad news is that I don't have any data for you because I just got here 4 months ago. But that being said, what I'll try to show you today, rather than data and details about production systems, is a more broader idea of how strawberries work around the world. With a quick show of hands, who here has been working with strawberries between, let's say, 1 and 5 years? 5 and 10, more than 10. You see, most of you already know more about strawberries than I do. And what I can do for you here, however, is instead of giving you details of things that you do every single year, every single season, what I'm trying to bring is 2 things. First, I'm going to show you a couple of things that happens outside the US. And second, I'm going to hopefully help you get a better idea of how things work on our end in the scientist's mind when we try to do science. Something that most people don't understand is that science it's a very. Am I pressing the right button here? So let me see. Is it coming? No. There we go. I don't know why they put it on. So science is pretty repetitive. It sounds pretty fancy every time a scientist comes and shows all the analysis that we can do. But on the back of that, we are basically going to the field and taking notes and trying to find out if what happens this season is going to happen next season. If it's kind of similar to what we saw 2 or 3 years ago. So in a simple way, we're basically looking for patterns. That's all we do. If we don't see a pattern, that means that we don't know what is happening. If we see one, then we kind of have to figure out why that is happening. In fact, I'm not making this up. Many scientists in different areas kind of define the work that we do as trying to find things that get repeated in time. These are real quotes. The one that I like the most is this one: science is a search for a repeated pattern, lots of regularities underlying the display. Now, that being said, I would like to see if we can all try to find patterns on the strawberry industry across different countries. And I'm going to help you. I'm going to kind of walk you through this. So here we have the word map. And what we're going to do is trying to find, I'm going to list some of the top 10 strawberry producers in the world. And we're trying to see if we're going to try to see if we're going to find some patterns here. First, we're going to start with US. We got the big player, California, on that side. And we got the second biggest player, Florida. We know those two systems extremely specific for what they do on the west side and on the east or southeast side. Then, if we get out of US, we go a little north, Quebec and Ontario, which are this area, produce about 68% of the strawberries in Canada. If I keep moving east, one of the biggest strawberry producers in the world is Spain. And there's reasons for that. One of them is cheap labor that comes from Africa, especially Morocco. But if you zoom in into the map, you're going to see that most of the strawberry production is located in this area right here. This is Huelva and Cádiz. And between these two areas, about 80% of the strawberry is located. So something neat that is happening there is, of course, the microclimate that they have, but also it's pretty close to the water, which is kind of similar to what happens in California, isn't it? Or in Florida, right? So that's kind of cool. In fact, most of their strawberry vegetable production is located in Almeria and Murcia, where they have most of their greenhouses. It's also in front of the water. So that's kind of neat. If we can move in east, Turkey and Egypt, also huge strawberry producers. And again, if I zoom into Egypt, we're going to notice that most of the strawberry that they produce in this village right here, which I'm not going to try to pronounce, but it's right there. And also, it's in front of the water, which, again, kind of sounds like what we do here in Virginia Beach. Now, if I keep going east, we're going to get to a real big player, #1 producer in the world of strawberries, which is China. And by, near that area, Japan. If we zoom in there, in the case of Japan, the first research, the first few plants that got into the island, got into this area right here. In the case of China, which is on this side, most of their strawberry is produced in these three regions: Hebei, Shandong, and Liaoning. About, I think, 62% of the strawberries. In the case of Japan, everything started in Nagasaki, but then you just move across the island. The whole island is basically producing strawberries. So again, you kind of have certain patterns of where the strawberries are located in different parts of the world. Now, again, if I go to my map, this already here kind of looks like something is happening in some areas of the map, right? But again, we have our biggest competitor is not any of those countries, it's actually Mexico, right? So let's see what is happening with Mexico. If we get into Mexico and you see the map, if you look at it, the areas that produce the most strawberries, Guanajuato, Jalisco, and Michoacan are the areas where most of the strawberries get to the States. Now, something kind of changed here. So we were looking for patterns near the water, but once you get to Mexico, they kind of went away from the water and got into the middle of the country. So that kind of breaks the pattern. They went from, the coast to high elevation. So that already kind of makes things a little weirder. But if we go back, you can kind of see that there's a particular area where most of those countries, which are within that, are producing strawberries, right? So that's one thing. That's cool. But then, if I keep moving down, I go south, which I know is going to be a bit hotter, so temperatures are going to be higher. What I notice is the countries start to produce in higher elevations. So they move away from the water, they start producing higher elevations. That's the same thing, and that's the same thing that happens in Venezuela, Colombia, Ecuador, the Caribbean, and most of Central America. So two neat things that might happen there. First, the water is definitely playing a role. And then if it gets hot, I gotta go high in elevation. And I promise everything that I'm saying right now is gonna get back to flower induction. I just want you guys to, keep in mind what is important across the whole globe when it comes to producing strawberries. Now, just to make sure that we're talking, about the right thing here, if this is an area where we produce strawberries, and this is the North Hemisphere, this is the middle of the globe here, right there in the Ecuador, and I was taught in high school that the North Hemisphere and the South Hemisphere have similar climates once you start matching the latitudes away from the equator, right? If that makes sense, then that means that this might be another neat area to produce strawberries. And if that's the case, then the countries within that line should be, big producers. And that's exactly the case. Chile is one of the biggest producers in South America with Argentina of the strawberries. In fact, Chile played an amazing role in what we call the modern strawberry today, which is what you guys plant. South Africa also plays a big role, and Australia is a big player when it comes to strawberries. So right there, hopefully you guys are already seeing kind of a bit of a pattern where the strawberries are being produced around the globe. Does that make sense? Nice, okay. Now, two key questions arise from that. First, why do strawberries perform better in certain regions? And second, what environmental conditions are influencing the plant performance? Why it's happening? What is playing a role there? Well, to understand that, we gotta combine a few factors. The first one is the history of strawberries. And I promise you this, I don't know if you know much about history of different vegetables, but to me, strawberries has one of the most amazing and personally cool stories that you're gonna hear when it comes to the origin. I promise you that. First, let's check on the name. Fragaria X, that means by ananases. If you have any other plant, like tomatoes or pineapples, rice, they have particular and scientific names, but none of them have that little X right there. Strawberries is one of the few that has that. And the reason for that is because what you guys plant is actually a hybrid between two plants, Fragaria virginiana and Fragaria chiloensis. The Fragaria virginiana is also called scarlet strawberry or the Virginia strawberry. So we are already playing a role in the history of strawberries. And the reason for that is that particular species was one of the first ones to be moved from the Americas to Europe. In Europe, they were producing Fragaria vesca, Fragaria moscata. Those are two completely suited species. We don't even play around with those here. But once they got, the England got into the States or into the North America area, they found the plant, they took it, compared to the vesca, which it was kind of like this, it looked like that. The vesca was a smaller fruit, it didn't taste too good, and the plant was small. Fragaria virginiana, however, it was a bigger plant, and it could survive worse weather, and it could survive for longer. In fact, the fact that the plant was moved from one continent to the other in the old days by a boat make it really expensive, and they didn't know how to produce it. So it kind of became something of the royalty to actually get strawberries. In fact, we can see that in different areas in history. For example, here, the Madonna among the strawberries, you can see the strawberry plants growing here in the back. Here in this particular book, you can see the strawberries being presented both as flower and as a fruit. Now, that's nice to know, but what does that have to do with, with you and the whole big picture that we're trying to paint? Well, the other thing that we have to remember, or if you don't remember, at least it's kind of cool to know right now, is where these two words come from. Us scientists tend to see things and give it names based on what we think it looks, believe it or not. We are not that smart. Like if we see something that looks like a tree and we know, another tree, we're gonna call it second tree. That's easy to remember. Now, Frago basically is Latin for an aromatic fruit, strawberries. That's why we call Fragaria virginiana and Fragaria chiloensis. You can kind of figure where the Virginiana came from. You can kind of figure the Chiloensis where it came from. This is from Virginia, this is from Chile. That's why we call it Fragaria virginiana and chiloensis. In fact, Fragaria vesca basically means aromatic fruit because Fragaria comes from Frago and vesca means it's a Latin word for small, thin, and weak. Remember the picture that I showed you? That's basically what it means. In fact, the word strawberry is probably a corruption of the combination of strew berries, referring to the runners because they strew away from the plant. And that's probably, we don't know, but that's probably where the actual strawberry word came from. Now, back to what I was telling you about the cool story about strawberries. We're going to go from French spies to crazy botanists. This is amazing to me. So we got the Virginia strawberries. Those plants were moved to Europe. They were grown there, and they were not. It was a big plant, but they were not producing as many ripened fruits as they were expecting, or at least as they hoped to have. John Parkinson was an English botanist, and he described the berry as not being fully ripe most of the time. Now, at that time, and we're talking about the 1700s, French and Spain were trying to invade what is now South America. Because neither of the countries had a lot of money, Spain moved to Chile and was trying to have these different fortifications there, different areas where they have castles and things too, so they can battle the French. French, on the other hand, in this case, the king at the time said, all right, you know what I'm going to do? I'm going to send some of my spies to Chile, to Concepcion, because I want to know what the Spaniards are doing there. I want that guy to send me pictures or drawings of what is happening there. And that was what happened. King Louis sent this guy, Amadeo Franco's Fraser, to Chile to make drawings of what the structures that the Spaniards were building looked like. And he did exactly that. But he also found this little plant that he thought tasted really good, and he liked it a lot. So he sent a picture of the plant too, back to France. And when he finished his mission, he stole 18 plants from the native of Chile. He took it on a boat, took it to France. In France, then, they already had the Fragaria virginiana, which was, again, being consumed by the rich in that area. But once they put, by literally mistakes, or just because they didn't have space, once they put both plants there, they cross. And the crossing gave us what we call today our mother strawberries, which is the Fragarias biananasa. It's the cross of Fragaria virginiana and Fragaria chiloensis. This we have because of our French spy, and this we got because the English came here to the Americans and took it to Europe. How cool is that? Come on, that's really neat. Another interesting thing, believe it or not, is that although that's the story, like the history of this, and I hope you guys can see how that connects to the pattern that we have about the areas where strawberries are produced, one from Chile and one from Virginia. It really goes back to the two parents of the plants that we, the plants that we got right now. But another cool thing is, well, if this work here comes from Frago, what does the ananasa means? Now, that's kind of tricky. So once the new strawberry came to be, it had a pine shape, like the shape that you see of the strawberry right now. The common shape is kind of like a pine cone, right? So a botanist called last name Duchenes thought, all right, that kind of looks like that strawberry kind of looks like a pine cone, and a pine cone basically is the same shape or similar to what a pineapple has. And I know that the word ananas, which is this is scientific names for pineapples, means excellent fruit. And I know this new strawberry is better, so I'm probably gonna call this the pineapple strawberry. That's why you see here the pineapple or ananas strawberries. And yeah, that basically means that we all today call Fragarias biananasa our strawberry because this guy thought that kind of looks like a pineapple or a pine cone. So you see what I'm saying about us scientists? We kind of, we need something to name other things. But anyways, that's the history part. So yes, the two species that gave us the modern strawberries came from the two areas that are within the patterns that we saw on the first map. The other thing that you need to know is basic anatomy of the plant. And hopefully this will relate a little more to your production systems. Where the first thing is, we got crowns, stems, crowns, roots, leaves, flowers, and fruits, right? First, let's talk about the crown. Many people consider the strawberry to be a little bush, but it's not. Actually, the crown is a compressed stem. One thing that it has is a secondary xylem. A secondary xylem is something mostly related to woody plants, something like this little piece of like lines that you see here in the wood. That's the secondary xylem compressing the phloem of the plant. That's why you see those lines. And the strawberry crown actually has that. And we cannot make wood out of strawberry, but it looks more like a woody plant that is a bush. So that's something to know. Also, it has meristems, which is basically the area where everything grows, leaves, roots, and everything. So from the bottom part, we get the roots. From the top part, we get the leaves, other crowns, and the flower. The roots, we got basically 90% of the roots in between the first 10 to 15 centimeters. Then we got the runners, which basically arise from the crown. And here comes the first, I think, cool question. Have you ever wondered why you don't get your plants from seeds? You have any idea why? Instead of, the way you have tomato seeds, or you don't have strawberry seeds to grow, you get, clones. The reason for that is because most of the modern strawberries are what we call autoploids. the way you gotta think about this is us, we got, my mom and my dad, they combine, they're that's called being diploid. Basically, you got two, right? Two sets of chromosomes that get combined. I get the here. Strawberries basically come from a combination of what we call 8 parents, different parents. That's why we call it octopods. Bottom line of that is that if you try to take a seed of what you think is a nice strawberry, it is extremely unlikely that you're going to have those same traits on the next plant. And that's why nurseries cannot give you strawberry seeds, because they don't know what you're going to get. They are what we call a genetic mess, basically. And that's why we get clones, which are the runners. The runners are what become the bare roots or the plots, which are the plants that you get here, or the frigo plants. So a runner is basically a clone of the mother plant. They get the cultivar, they develop the new cultivar, produce runners, and they send you the runners. Then you got the flowers. The flowers are, again, it's a complex structure, but something that I like you to remember is the pistils. The pistils are the feminine part of the flower. This is extremely important for you. Now I'm going to show you why in a second. The last thing is the fruit. Of course, believe it or not, strawberries are not berries. Do you know that? They're more similar to a dry fruit than they are to a fleshy fruit, because the actual fruit of the strawberries are the little seeds you see here. They're called achenes. And given that we have a bunch of them in what we call the strawberry, there are complex and composed fruit, and they are, you see that any of those seeds, none of those seeds have any flesh around there. They just stick to the fruit. Therefore, they are dry seeds. They're more similar to nuts than they are to anything else. What you eat, in fact, is the receptacle of the flower. Whatever the flower is sitting, that's what is going to start expanding, getting water and sugars, and that's what we eat. Now, back to, hopefully I can get back to the flower. This number right here, 60 to 600 pixels, refers to the female part, which is what is going to turn into those small seeds. And this is extremely important because the more seeds you have, the more auxins, the hormone, are going to be produced, and therefore the bigger the strawberry. Now, how that plays a role for you comes here. This is a picture of a strawberry. All of you have seen this. Now, not many people understand what is happening here. You got your crown, you got leaves, you got roots at that point. I don't know if you have more crowns or not, but you definitely have flowers. Now, the strawberry doesn't produce a bunch of flowers at the same time. It goes 1, 2, and 3, and 4, and so on. The first flower that produced in the inflorescence, which is the combination of all those flowers, is called the primary fruit. And it just so happened that that primary fruit is the one that produced the most pistils, meaning the more seeds. And therefore, your primary fruit is your bigger fruit, the biggest fruit you're gonna get. And I promise you, you have seen this. It might be just the case that you haven't, combined the dots yet. These two right here are the secondary fruit. They will come after this one. They will not produce that many pistils, therefore they will not be as big. And then you got tertiary fruits like this. And again, things don't happen at the same time. You might have a fruit here, which is your primary, secondaries, and you still have get tertiary fruits and flowers. That's why you see the combination of flowers and fruits at the same time happening in the plant. Now, how have you seen this? Just like that. This is a trend, it might be similar to your field or not, of a weekly strawberry yield, right? And what usually happens is that once you start your harvest, you're going to have a small peak, right? And then things are going to come down. This right here is your primary and secondary fruits. Once you start getting to your tertiary fruits, the size of the fruits are getting down. Therefore, your weekly yield goes down. And then each crown can produce either one inflorescence, at the most 2 inflorescences. because you need a second crown to get, again, a primary fruit, your yield goes down. So at this point, you harvest a couple times, things start going down, going down. The plant used this time to produce a new crown, a new inflorescence, and then things go up. Does that look similar to what you might get some, in your season? Because that's most of the cases, this is what happens. And then again, it goes down. You already, harvest everything from your inflorescence, and so on, and just keep going from there. Now, I've been talking about runners, crowns, strawberries, fruits, and I promise you all this, it makes sense. It's all connected here. I'm gonna take the plant, we talk about the inflorescence, talking about the runners and secondary crowns. If I wanna get inflorescence, flowers, what does need to happen, right? And the question is what trigger each of these parts? And here we get to the flower induction part. What triggers the flower is a bunch of things. Genotype, cultivar plays a huge role. Plant maturity, a small plant is not going to produce a flower. It needs to grow first. Hormones concentrations comes with the maturity, and nutrient or water availability, are going to play a role. If you don't put water or fertilizer, it's not going to grow. Therefore, you're not going to get any of this. Now, all being equal, it all comes down to photoperiod, meaning hours of sunlight, and temperature. You probably have seen this before. First, we're going to talk about photoperiod or hours of sunlight. Most plants are classified as either short days or June berries, long days or everbearings, or day neutral. This is the most common classification. Although it's not really like that. It's not the way it works. This classification is mostly to simplify things for most people. The real way it kind of works is that plants are not day responding, but rather night responding. And I'll show you how in a second. So if you have a short day plant, for example, you have, let's call it a long day and a short night, it's not going to flower. That makes sense because it's classified as a short day. If I get to a short day, or which is the same, a long night, it might flower. Now, with different experiments, we got to the point where we start playing with interruptions of both of these cycles. It so happens that if you get a short day and you interrupt the short day, meaning that you give the plant, let's say, an hour of dark, but within the day, it will still flower. But if during the night you interrupt the night, that plant won't get flowers. Meaning that the actual response comes from the longer night rather than the short day. So again, it's just extra information for you, so make your life more complex than it already is. With the long days, it kind of works the same. It's just short nights playing a role there. Again, when it gets even more complicated is, although you might have your photoperiod already determined by your season, because there's nothing that you can do to actually influence the hours of light other than having a greenhouse with electricity. The other thing that plays a role is temperature. You probably already know all this. You know the induction cycles, or what we call the chilling days, and how they are necessary for the flowering. Now, something neat here is that it just so happens that although temperature plays a role, the actual triggering of the flower is a response of the combination of the photoperiod, like I was saying, with most of the time low temperature. So, for example, we had a June berry right here. This is an old trial. This is kind of generalized, very known. But here we got the temperature of the day and the temperature of the night, and they start to increment. The higher the temperature, it doesn't matter if you have your plants in a short day condition, they won't flower. You need the combination of low temperature with the right photoperiod, so you can actually have the flowering that you need. And that's why you don't determine your season, but rather you adjust your planting to the season. Does that make sense? Strawberry is one of those crops where most of the work is done before you even put the plants in the field. If you know when you're gonna get the right temperatures and the right photoperiod, you're playing the right game. And that's how we determine the way, we have different seasons for each state and different countries. It's basically giving you a graph like this. The higher the temperature, the more you're going to get to vegetative development. It doesn't matter how low the photo period might be. You still, if you have a higher temperature, you're going to end up here. If you have even a long photo period, meaning a lot of hours of sunlight, if you get a low temperature, you're still going to get to reproductive development. And again, this change between cultivars, but that's kind of the main idea of how things work. Now, you know that. What I want you to understand is that this is not new. It's not even close to new. For example, here is a map of the strawberry producing areas from 1940s in the United States. And you can see what areas are already producing strawberries. If we move to the 60s, it kind of looks the same. If we get to the latest one, kind of looks the same as 60, 80 years ago. It doesn't change because we cannot change it because it depends on the season. It's temperature and light playing a role. We might, influence things by changing the cultivar, playing around with different color mulches, things like that. But at the end of the day, this is the bigger picture behind us. That's why all the strawberry growers need to plant at the same time. And I'm going to show you even this one right here. This, it doesn't have the year, but I'm pretty sure this is around the 60s. It will give you the time where most of the first harvests start in different areas. Here is Florida, the 60s. We're still harvesting in this time. And I'm pretty sure that we're not too far from this dates right here when it comes to Virginia. Now, what happens when we don't get those conditions? Well, you will think that's bad because we don't have fruits. Well, not so much. If you don't get fruits, that means that you get runners. And if you get runners, that means that although you don't get fruits, the people who sell you the plants get to sell you the plants. So I don't know if you see how this cycle is kind of getting to a final connection here, but there's two industries here playing a role. There is you, and there's the nurseries. You're playing the fruit game. They're playing the runners and leaves and crowns game. Now, because you're trying to influence the flowering, they're doing the opposite. They don't want flowering. They want the runners. So they kind of adjust to how the plant works. For example, this is a graph of the temperature on Red Bluff with Crown Nursery is in California, or at least one of their farms. And I'm going to try to walk you through the way they do their system. And hopefully this is going to explain why you most of the time can only get plants and bare roots and plots in a specific dates in the year. And it's kind of hard to get it in other dates. So the way it works for them, they usually put their plants, what they call mother plants, in November near to December. The plants are going to survive the winter. They're not going to grow a lot. But then somewhere around here, although they were dormant, they start breaking dormancy and they start growing. They might get a few flowers or whatnot, but because the temperatures are going up, the plants start to develop and grow. Around this point, the plant does not have the flowers because the temperature is already high, and they start producing runners, which again are going to become your bare roots and your plots. And then around this time, September, October, is when they say, well, we got the final product, we got to start shipping. It's already done. We got to start moving it to Florida, other parts of California, and other southern and western states. Now, something neat that also happens here is, if you notice, around this area, right here, where September, October is, the temperature is already going down. And if you remember the graph that I showed you about the temperature, once it passes certain threshold, the plant is going to start inducing the flowering. It looks like that might not be good for the nurseries, but it's actually really good for them because what is happening is that within those late 30 days before they start chipping, the plants that they're going to start chip, they start to get induced. Therefore, by the time that they get to you, they get to the Florida growers. They already have induction, so once the Florida growers or you put it in the field, those plants are going to develop roots and they're going to start flowering right away. Now, they're going to start flowering because the leaves already are induced. The more leaf you produce, they need more induction cycles, and that depends on where you're at, meaning that the Florida growers are going to see that first peak right there, and then they need the temperature for them to be good so they can have more flowers because they got induced there. Something similar happens with the photo period. The threshold for most plants is about 14 hours, and they need different production cycle. Induction cycles. And therefore, at this point, right before they start sending to big strawberry producers, they get the induction. The way I can show and prove this to you is by showing you how the Florida system works. Florida plants most of the strawberries in October. Once the temperatures start to drop, they try always to match the highest price, which is this line right here, and it's usually around December. So by the time they get their plants in October, they have already the induction from the nursery. They put it in the field, establish really fast, get the first flowers. 40 days later, they get the first harvest in December. If you remember that map from the 60s that I was showing you, December 1st, late November is when they start harvesting. I've been talking a lot, but hopefully you can start seeing how things start to, combine, how the nurseries adjust their systems so big growers can produce a lot, and that's why you can only get your plugs or your berries in certain dates. It's all because of the photo periods. It comes back to the species that we actually use to produce the, modern strawberries. So yeah, things get confusing at this point. This is a weekly chart of already induced plant. Like I was saying, first peak. This part right here is a combination of the crowns getting developed, new inflorescence, and the flower induction that need to happen. And if you get your plants and they don't get the induction from the nursery, something like this might happen, where you barely have any yield at the beginning, and then you got to pick because the plant basically spent all this time getting bigger, and by the time you got induced, you already had a bunch of crowns, and therefore you got a big yield at the end. These two graphs produce about the same average yield, but one of those two is producing more money at the end of the day. Because most growers, again, in this case, in Florida at least, they want their fruit here because the prices are high. Therefore, this, although it's producing the same at the end of the season, it's not producing as much money as this one. That's why Florida is big in strawberry production. So just to start to wrap this up, hopefully you understand this pattern here, understand how things work here, and why things are like they are here. In terms of the big producers, they basically have different planting dates depending on where they are in the different areas, especially in California. Florida usually plants everything at the same time, and we have different regions for production. If you notice, most of the Southwest states are within the same region, which is a little different from Florida because Florida is aiming a different production system, a different price, while we are a little colder than they are. Therefore, our system has to be different. That's why if you ask me, I'm from Florida. Well, I'm not from Florida, but I spent many years there. If you ask me, well, what can we do that they do in Florida so we can increase our yield? Well, nothing, because their system is so specific to them that we cannot apply many things that they do down there. And it's the same for California. If you start to even get things even messier, you got regions, production systems that change, planting seasons, different transplants. Here's a list of cultivars that are produced around everywhere in harvest season. And like I said, it all comes down to the microclimate or the zones that we have in different production areas. If you don't believe me, this kind of applies to all those countries that we were talking about. For example, this is the strawberry production in Japan, how it works. Right here is the peak of their production, which come down around, we got January, February, March, April, May, June, start coming down, and then they have nothing. They plant the strawberries around here, and they come up. If I didn't tell you that this was Japan, I could trick you into believe that this was US, right? Because it's about the same planting dates, similar yield, similar pick, right? And it's because of the same thing. It doesn't matter if we're growing things in Japan, they're still in the same area, that same frame that I show you here, as we are. Therefore, their conditions are similar. Therefore, their system is similar to us. That's why they produce, that's why we produce, that's why here in the middle things are a little different. I got a lot of proof about this. This is a production system in Mexico. Mexico is down a little down south, but they produce in high elevation, therefore they can match our curve of production to the point that this is the price line that I show you in Florida. Like I was saying, high price in December, things start to go down in February, and that's because most of the Mexican strawberry start to get produced and start to get imported into the US, therefore the price goes down. Let's keep moving. Europe. Europe have different production systems based on where they are. If you're north, then you're going to start probably producing with protected agriculture. If you're down south, you got something more similar to what we have here in the States. At the end of the day, if you don't remember all I just said, remember this. Strawberries are a complex system, and it's better to understand the fundamentals and adapt them to your system rather than try to adopt something from somewhere else. It's not necessarily going to match your system. It's better to, try to adapt and improve your system. And that's why things like the research that Jaesh is doing, the research that Lorena is doing, which is local research and is focused on your needs, has more value than anything that we can find in any other state or any other country. Because the more specific we do it, the more it's going to help you rather than just try to better things based on what other people are doing. So, I was saying they're complex. We need to understand the factors that play a role here. Locally generated information or research is primarily for strawberry productions. I know I talk a lot today, but if you like the way I talk, you can reach to me. Here's my phone number, email. Like Jaesh, I had to jump into Facebook. So here's the connection. I haven't get into Twitter, but I got LinkedIn, so that works too. You can text, you can call. Although my specialty is vegetables, I'll be happy to help you with strawberries if I can. And with that, thank you.
It's going.
That's the second time I've heard that, and it still blows my mind.